Welcome to this DevCon session on getting started with the iTwin platform.
And iTwin.js, and the iTwin viewer, and a bunch of stuff.
My name is Roop Sani.
And I'm Bill Gehrig.
In this session, we're going to walk you through how you can get started with your own iTwin platform-based application. We're going to do two main things. One, we're going to go over the iTwin viewer, which is the starting point for your iTwin platform application. And we're also going to go into some iTwin APIs and see how they enrich the iTwin viewer to help you build your own digital twin solution. So to start out, I'm going to hand it over to Bill, who's going to talk about the iTwin viewer and walk you through the basics.
Great, thanks, Roop. So before we get started, I just want to say that this video is going to presume some base familiarity with iTwin platform, digital twins, and some of the core concepts in iTwin platform, like iModels. So if at any point you're lost about how to store engineering content in an iModel, feel free to check out our iTwin Developer Accreditation videos. They're a great way to get started and familiarize yourself with some of the core concepts in iTwin platform. So, as Roop said, we're going to start with the iTwin viewer. It's important to remember that the iTwin viewer is a digital twin viewer. It's not just some file export viewer. And it's really easy to get started with the iTwin viewer. All you have to do is go to the Getting Started section of our iTwin platform website. We have a quick start on setting up a new web viewer. It's really easy to follow. And as you already saw, I've already gone through that tutorial and bootstrapped myself an iTwin viewer sample here. So the only thing I actually changed about the code, it's worth pointing that out, is I added Bing Maps here, just to really emphasize that we're not just looking at an iModel here. It's not the iModel viewer, it's an iTwin viewer. And so we can add maps, we can add reality data, we can add all kinds of other sources into here. Now, one thing to point out is that there's a whole lot going on here, right? We have 3D graphics, we have some chrome around the edges, we're able to zoom, pan, interact with property data, and navigate via the models tree here. There's a whole lot happening. So I think what we should do to start and really understand what's going on with iTwin Viewer is to sort of break it apart. So I like to think of iTwin Viewer as being built up of a bunch of different systems. And three key systems that I want to emphasize in this talk are display, presentation, and UI. These are independent systems that come together in the iTwin Viewer to really build rich user experiences and really powerful digital twin applications. So we'll go one by one through each of these. And to start, let's start with display. So the display system in iTwin.js is a tile-based WebGL rendering. Worth noting that iTwin.js is the only viewer that natively supports the iModel tile format. iModel tiles are inspired by GLTF, but they're specifically optimized for engineering data.
So Bill, does that mean that, because it makes me think that you can, the iTwin viewer is the only thing that can open iModels. Is that real, or the iModel data?
No, so that's a great question, Roop. You can absolutely view iModel data in other rendering engines. All you have to do is export the graphics out of the iModel, and then you can send them into game engines like Unity and Unreal. Matt's got a great talk later today about that, so be sure to check that out if you're interested. But yeah, the iTwin display system in iTwin.js is really just it's vanilla TypeScript. There's no UI framework dependencies at all. And it supports, like I said earlier, a ton of different data sources all together in the same application. So why don't we kind of build up the iTwin viewer as we go here? So I've went ahead and put together a little sample vanilla TypeScript demo because, of course, the iTwin viewer template starts you out with our React component, right, which we'll talk about in a bit. But if we want to kind of start from scratch, let's start with the real bare bones TypeScript example here. So that's what I've got here. As you can see, it's only one file. I'll hide that. And there's a little bit of junk at the top here, a lot of imports, right? So we'll just scroll past that. And then everything you see on screen is the whole viewer I've got. So what's going on here? Well, there's some boilerplate to set up auth and sign in. There's some boilerplate to initialize iModel app, which is sort of like initializing your whole iModel front end with iTwin.js. Then we set up our connection to the iModel access service. So Roop's going to talk about a bunch of other platform services later, but to start, the viewer you get right out of the box is really talking to primarily two different iTwin platform services. The iModels API, which is all about retrieving an iModel, and then the iModel Access service, which is about opening up an iModel and accessing the information within the iModel. So the viewer uses the iModels service to ask for change set information before we open up a connection to the iModel Access service, which is set up down here. And then these last 5 lines are the real key here. This is where we're creating a view state using the View Creator 3D class, which Roop wrote, by the way.
Yes,
And then all we have to do is create our viewport, we add it to the DOM, and we tell iModel Apps View Manager that we've set up a viewport. So I've...
real quick, Bill.
Yeah?
So you're just adding a viewport directly onto a DOM here.
Right. No framework, no React. If this can work in any framework you want, or no framework if that's your thing.
And they can use it to integrate their current web application as well?
Yep, yeah. So I'm going to go ahead and npm start this. You'll be able to find this sample on GitHub, so you can just clone and npm install and npm start that. And we'll come over here and we'll go to the window where this is, put it up, and right out of the box, this is what we get. You see there's no Chrome around the edges. It's just the display system. Now I can still interact with the display system because we still have view tools enabled here. There's just no buttons to instantiate them or start them. But I can still pan and zoom and interact with the view in all the default view tools that we have enabled. But that view tools brings up an interesting point, which is when I reload this page here, I get something a little different than what we got in the web viewer, right? This is a top-down bird's eye view. So I'm just going to come back and I'm going to check out my tools branch, which adds 2 more lines down here to use the standard view tool and the fit view tool to rotate and then fit the view in that order. So if I save this, I come back here and we're going to reload. And now we get a view that looks a lot closer to the sample from before that was using React. But again, no React here.
So you directly use the tools.
Right. You don't need the UI to run the tools often. Some tools have tool settings and really are a lot more back and forth with the user. So in that case, you would need to use some kind of UI. You have to provide some UI. And we have some samples on GitHub for some bare bones UI just with vanilla TypeScript. Be sure to check those out. So that's kind of an overview of what a display-only viewer would look like, right? Now let's move into our second system, which is presentation. So presentation is all about accessing the data in the iModel and transforming it into a view model that's usable for UI components, right? We have a lot of these data-rich UI components in the iTwin viewer. Specifically, we have the property panel and we have the models, the navigation tree. So presentation allows us to declaratively define these presentation rules, and the rules define a perspective on the data in the iModel. Remember that an iModel is not a file export format. It's really a format for storing aligned engineering data in a digital twin. So what presentation really allows us to do is to transform the data in an iModel, which is in an optimized persistence format, into a format that can be used as a view model for these controls. So let's take, and it's also worth mentioning, under the hood in presentation, it's using Biz and EC SQL, the understanding of the information that Biz enables for us, and the query power of EC SQL to retrieve that data from the iModel. So this is all happening in the iModel Access service, and it's a great and easy to use way to build these view models for these controls, because you don't have to handcraft all these EC SQL queries. That can be kind of a pain.
And we're getting this data from all these different domains, and
right.
And the presentation rules help us
right. And presentation rules also lets you define sort of domain specific rule sets and perspectives on the data, right? So there's a lot of there's a lot going on in presentations. One of the most underrated and powerful things happening in iTwin.js. So I'm going to, again, check out my branch. This is like a cooking show. I've prepared all this ahead of time. All I've really done here is I've added a presentation RPC interface because we're going to talk to, still talking to iModel Access Service, but that set of functionality in iModel Access Service. And the other thing I've added here that I want to call out are two rule set JSON files. So I won't get into the weeds of how you define these rules. Be sure to check out the docs if you're interested in that. There's great documentation for presentation. Guys that work on that are geniuses. But I want to just scroll down here past our tools, and everything we have here is interacting with the presentation system. And I'm just going to blaze through this real quick. We set it up, we download the rule sets, then we can, these are sort of two things you can do with presentation are get hierarchical nodes that power like a tree control, or you can get content which powers things like tables, lists, and property grid. And most of what I'm doing here, because again, presentation is not very graphical, we're just going to dump some of the output to the console in Chrome DevTools. So if I reload here and I pop open Chrome DevTools, first thing we see is our tree, and this is the models tree. And so for the sake of this demo, I've added the children on here. It's important to note that the tree data provider that presentation gives you is lazily loaded, right? So we only load one level of nodes at a time as they're expanded. I've just gone ahead and preloaded a couple of these nodes so that we can see the data structure here. And it's a lot more than just the labels and everything. It has,
real quick, Bill, I'm curious, for people watching this, where exactly would they use this output? Like, what would be the situation where they might need to, make use of this? Yeah,
so you can use this in all kinds of ways. The ideal use case for this is, like I said, powering UI controls, these data-rich UI controls like trees and tables and property panes. This has everything you need to build a data provider for those controls. Of course, if you use our React components, that's all done for you, and you don't have to deal with any of this. It works right out of the box. But if you're not using React or you want to build your own controls, this is like everything you need wrapped up in a bow for you to use. It's got the labels that you see, but it also has everything you need to track it back to the instances. That's how the unified selection works. And it's got lots of other information, like whether it has children, whether it has images. A lot of thought has gone into how this should drive a UI component.
Okay, you mentioned unified selection. Can we get more information on that?
Yeah, so unified selection is basically the idea that we're going to tie the selection set of what's selected in the viewport in the display system back to what's selected in the presentation system, which means in practice selected across all those other controls you see in the screen, right? So property panel, the tree. If you select something in the tree, it should bring up the property panel and it should highlight in the view. And that's exactly how this works. One line of code I added in our sample here is right here. This is all about synchronizing the viewport selection with presentation. And from there, everything's all wired up, and I can collapse this tree. If I click something here, I get the content set and the content descriptor for that selection. So the content descriptor kind of tells us how to build the control, how to lay out the property grid, and then the content set is how to fill it in with the data. And we'll see that more later. So that's it for presentation. Like I said, it's a huge topic. There's tons of documentation to check out. And it's really, really worth your time to learn about how presentation works if you're going to go the route of building your own UI and not using our components like the property grid. So the last section here is our UI. So I mentioned some of these data-rich controls, the property grid, the tree. But just to kind of back up a bit, if we go back to our initial sample, which was using the web viewer template, this is all coming right out of the box for us. And if we go to the source for this web viewer, we'll see that we have a viewer React component. And this is really like a batteries included. Everything is all set up for you to start building an application. It's a great way to bootstrap yourself and immediately have an application to work with. And it's very extensible. Arun and Caleb have a great talk on extending the viewer.
It's next up after this one.
Yeah. So going back to my slide on the UI, really what I want to talk about here is that you can use as much or as little of our UI system as you want. So going down, sort of from top down, you have the viewer component. That's, like I said, batteries included, comes with everything. And then the next step down from there is App UI, which is our framework for building the whole application. It's what's powering the widgets and how they dock and how everything's organized. App UI also defines UI providers, so that's a great way to extend that. Setting up all the interactions between all these different components is kind of tricky, and App UI kind of does that for you. Then the next step down is you can use the individual components and reuse those without tying it all together with App UI. So if you just want the property panel, you can use that on its own. And then all the way down at the bottom there, we do have iTwin UI, which is our design system. And if you don't want to use React and you really like our styling, the way our controls look and feel, you can still get a lot of that just by reusing the styles and markup. Of course, you have to build the behavior of all the components yourself. But yeah, so once we bring all these pieces together, the display, the presentation, and the UI, we're back to where we started with the viewer template. And there is one thing I do want to show, which is that I lied at the beginning of this. I said I only changed one thing to add maps, but in fact, I also added my event listener for dumping the content into the console here. So we can kind of see a side-by-side view of what's in the property panel and what's in the content here. So we have a content descriptor, and I like to think of the content descriptor as like the left-hand side property panel. It defines all the categories, how things get grouped here, the labels, not just the labels, but like where those properties come from. Because we're not just looking at one EC instance here. There are lots of different related instances and aspects and everything you have to combine. So presentation is amazing. It does all that heavy lifting for you. Then the content set is just, the values. And so when I have multiple things selected, it's going to find like the union descriptor and then give me two pieces of content, right? So yeah, that's kind of everything all brought together, right? Under the hood, you've got presentation kind of driving a lot of these data-rich components. And then, of course, the display is really cool to look at. And like I said, this is only scratching the surface of what the display is capable of. You can have reality data, you can have point clouds, you can have terrain data, you can have maps that are actually geolocated correctly and not just some random point on the Earth like some of our sample data sets.
Where is this? Singapore?
I think so. That's all in how you connect the data with connectors. But yeah, it's a really powerful display system. It's a really powerful way to build digital twin applications. And like I said, there's a lot going on under the hood. Hopefully now you understand it a little bit better. And now I will hand it back over to Roop to show some of our iTwin platform services.
Whoa. Well, what just happened?
We switched sides. There was a transition.
Transition it is. All right. So thank you first off, Bill, for the really nice breakdown of the iTwin viewer. So people at home who want to start out, you could directly use the iTwin viewer if you want to get started quick, if you want to use React. But if you already have a pre-existing application, or if you want to integrate some other web framework, then you can take up the parts, the display or the presentation, and then go from there. So at this point, we are going to talk about the iTwin platform APIs. Now, so far, we actually already have seen one of the iTwin platform APIs, Bill, which one was it?
That was the iModel Access API.
Right.
So that's where we were getting all of our iModel tiles, our presentation results, our query results, everything that we were reading out of the iModel came from the iModel Access API, which is not to be confused with the iModels API, which is what the iModel Access service used to download the iModel and what we use to get chain set information about the iModel. So I know the terms can be a little confusing, but they have very different roles.
Got it. And and then these APIs. So the idea is that they essentially pull in data that can ultimately enhance our digital twin application. So this is just starting out, visualizing the model. But beyond that, you can do so much more, and that's what the iTwin platform is about. We have a host of APIs that you can look at. There's a list on developer.only.com/APIs. Just click on documentation. That's a quick way to get to it. And we have a list of all our APIs, and there are way more to come. So what we want to do right now is demo through a few of these that are commonly used or solve important industry use cases. And we're going to quickly go through these demos, and we're going to use, again, the iTwin viewer, which we essentially are using as a starting point. And these are going to be different versions of the iTwin viewer that use all these APIs. So the first is the validation API. Now, what validation is, for people who are already in the industry, data validation is an important thing during the design process. You want to catch all your issues as soon as possible. And the validation API essentially lets you do that. The iTwin has the big benefit that you are bringing together all your engineering data in one place in a single pane of glass. You can visualize everything. And that creates the opportunity for testing the entire collective data of your project. So in this case, obviously, you have a very small model. It's called the Baytown plan.
Yeah,
so,
I recognize this one for sure. I see this a lot.
It's a popular model, classic. But I just want to show you, in this case, a very simple validation job. What we're doing is we're testing out the pipe insulation thicknesses of the pipes in this plant. And there are two results. Either insulation is too high or too low based on the project standards. And we've created a validation rule to test for this data and these elements. And you can see these different results. You can click on elements and zoom into the individual results.
So as you're zooming in, those are just display system API calls, right? It's all built in?
So the way I'm working with this right now is each of these elements have a unique ID associated with them. And I'm essentially creating a query to get a list of all my IDs. And
an easy SQL query.
Easy SQL query, yes. And that gives me, for example, the actual pipeline component that I'm going to be colorizing and displaying. And then I add effects to it, and I can zoom into it by passing it to the viewport. Yeah. So yeah, that kind of is a very simple example of the validation API. And now you can create dozens of rules and different types of tests, and you can reuse tests for different models. So it's a very, I would say, flexible API that can be used for validating your digital twin data. There is a course on this subject as well that recently came out. It's called the Validation API course, and we're going to add a link to that in this in the what do you call it? The show, the link.
Yeah, the show notes.
Show notes.
Sure.
The show notes.
We'll go with that. And you did a course on.
Yeah.
That was your course, right?
It was, yes.
Nice.
Such validation. Okay, so now this is only one part of the problem, right? We are detecting all our issues, but what do we do from there? Where do we go? So there's another API for that, which is called the Issues API.
Ooh, dark mode. I like it.
It is dark mode, you're right. So for people who missed this is the iTwin viewer in the default mode, and this is dark mode.
Well, by default, we follow the user's browser preferences.
Oh,
but
okay.
I snuck in and switched it to dark mode because
You messed with my code?
I did.
I
wanted to show it off.
Without my permission. So yes, this is the dark mode of the iTwin viewer, and the Issues API. So once we've detected all our issues in our design, we can assign these issues to people, keep track of our issues, and we can assign them again to elements. We can use unique IDs to identify different elements that have issues. And now we can click on a particular issue, and we can also capture a saved view. So we get a visual of where exactly the issue is occurring.
Nice.
And we can, as I said, assign issues to a person. There's a status for the issue and a state if it's closed or if it's open. And also there's an audit trail. So you get to see exactly the history of the issue, what's going on. You can also add attachments, pictures. So there's a bunch of different features here to keep track of your data related to issues and make sure that they're resolved.
Cool. So those saved views, that's basically just a persisted view state that we created using View Creator 3D earlier, right?
That's right. I believe so.
Yeah. So sweet.
It is nice, yes.
Yeah.
And you can persist view states like this.
So if I have a saved view, I don't need to use view creator and get that default view with all the categories and models.
Right, yeah, exactly. You can essentially save a particular view state of your model and restore it essentially as long as you have access to that view state.
Cool.
And Issues API is just one of the ways to do it. All right, so next up, let's look at one particular issue. So let's see if I can find it, clash. So this is a special issue because it's actually very common and it requires special attention, I would almost say. The reason it ends up happening a lot is because usually with engineering design, there's different people working on different workstations and they're developing a model. They might be working together on a model. And what this can do is there can be clashes where elements might share the same spatial 3D space. And that creates conflict. So
conflicts. Good thing those never happen in software.
What we want to do is we want to detect all our clashes as soon as possible, as early in the process. And for that, there's a clash API, which people can hook into. And it essentially runs a clash job and checks to see if there are any overlapping elements in the model. From there, you can start reducing your clashes. And as you progress to newer versions of the model, you want to reduce your clashes down to none, really, because down the road, this can cause problems.
So what are all those numbers and bubbles there?
So these are actually markers that we're clustering together.
Oh, cool.
And we can click on them and zooms in and kind of shows you, declusters them.
So everything that's going on there, the markers, the clustering, the coloring, the isolation, zooming, that's all built into the display system, right?
It is, yes, yeah. The markers we're adding on, they're called decorations that you can add onto the viewport, and you can put them on top of elements to kind of, give attention to different parts of the model when you have extra information that you're adding onto it. And also, if people want to learn more about it, there is the samples page. So they can go on to the samples link right here on the top, developer.only.com again. And there's a list of a bunch of these samples that demonstrate different things that you can do to the viewport. The markers are just the beginning. You can create heat maps. You can make it snow, make it rain.
I love the scientific visualization. That's a really cool one.
Oh, that one, yeah.
Yeah.
And you can search for these as well, right? So if you want to look for a particular sample, let's say you want to create markers. So you can just go to the search, type in markers, and then it will give you that sample. You can click on it, and you can actually look into the code, and you can pull that into your own application.
In a live sandbox. Cool.
Yeah, it's a live sandbox, so people can use the sandbox feature if they want to share code or if they want to experiment with the API.
And more dark mode. I love it.
Everyone loves dark mode.
Yeah.
All right, so that was Clash. Now I want to move on to the last API. I talked about as we progress different versions, as we move forward in our design, we want to capture clashes. Now this version history is an important tenet of the iTwin platform. What we do is in the iModel, we keep track of all the changes that are being made to a particular model, and also the different versions, who is making that change, and how did the model to its current state. So we keep this change ledger of all the changes happening in the model. And this creates an opportunity again for us to use all this data that we've gathered. And one of the uses is these comparing different versions of the model, which is called, it's in the change elements API is the one. So here's a sample for that API. This is a house model that I was working on. So in the latest change, what I did was I moved some lamps inside the house. And you will see that these are the different versions of the model. And here's one where the roof was added on the house, and then the windows were removed. So what we're gonna do now is
But these are named versions?
These are named versions.
Okay.
Yeah. So these essentially are...
These are like change sets that you've picked in the iModels API and highlighted.
Highlighted, exactly. Because that's when a significant event happened and it was worth noting and visualizing.
Cool.
So in this case, you can see we're comparing against the latest version. And what we have here is our model. And you can see in this version, the old version, there were no windows. In this version, we do have windows. So you can see they're highlighted in green. And we can also hide the things that didn't change at all. And now you can see we have windows, and we also have these lamps. Now you can see the lamps are marked as inserts. So if you hide the lamps are marked as updates actually, because they were moved. So if we hide the inserts, the windows, you can see the updated elements.
Cool.
Yeah. So
I love the changed elements stuff.
Yeah.
It's one of the most powerful things iModels are capable of.
it's yeah, absolutely. It's neat. And people can, again, go to the samples page. All the samples that we saw here, the source code for that can be found here as well, for all the APIs. So be sure to check out this the samples page, and just browse around and see any cool features that you want to try out. The idea is we start with the iTwin viewer. That's our foundation, and from there we can go ahead and incorporate one or many of these APIs to create custom use cases that you can ultimately use for developing your digital twin application and bring your solution to market. So yeah,
awesome.
That kind of wraps up my demo here.
Your tour of the platform services.
The tour,
yeah.
Yes.
Great. Well, thanks, Roop.
Yep. Bill, did you have anything to close out?
Yeah. Well, I'll just flip back to the slides here, and we can see we've got some links here. There's plenty more links. Like I said, all of our samples are up on GitHub. Feel free to check those out. And yeah, thanks for watching. Hope you learned something interesting somewhere. And yeah, we can't wait to see what you build with the platform. Good luck.